In this lecture, you're going to learn about smart casts, which are a very nice feature in Kotlin to make it easier to work with inheritance structures and again to avoid boilerplate code. So let's go ahead and create a new file for this again, and I'm going to just call this smart casts. And then let's go ahead and create a main function here, and then I'm going to go ahead again and create an object called vehicle. And I'll explicitly use the drivable interface as the type and then instantiate this to bicycle. So at this point here in the execution, the vehicle object or variable here is always just going to be of type drivable to the compiler, even though it is actually instantiated with the more concrete or more specific class bicycle. So this again goes back to this good practice I mentioned before to only use the most abstract interface you can. But in this lecture, we're actually going to use this to talk about how to differentiate between different types if you have to in Kotlin. So this is what's instanceof in Java, and it's just called is in Kotlin. So now at this point here, we can only call vehicle.drive because that's the only method defined on the drivable interface. But let's actually go ahead and say if vehicle is bicycle. So just like in Java, when you check for instanceof, it's just that the keyword here is simply is. Then inside here, you will actually now be able to make use of smart casts in Kotlin. But in order to actually see this difference, we're going to have to make some changes, or let's actually just add some extension functions to the bicycle and the boat classes, just so we have some kind of differentiation between the two. So for the bicycle, let's say we have an additional method called replaceWheel. I'm just gonna do a print line on that again. And for the boat class, we have startEngine, which returns a Boolean. So return type Boolean. And it's just gonna go ahead and print out starting engine. And then it's gonna return true. So this way now we actually have a way to differentiate between whether we're dealing with a bicycle or a boat. So now when I go ahead here and say vehicle dot to call a method, then you can see that now we also have the replaceWheel method here, even though we defined the object vehicle here to just be of type drivable. So in Java, when you have a condition like if vehicle instance of bicycle, then the next line is normally always something like val b is, and then you just cast the variable to a bicycle here. But that's not how you do it in Kotlin. So in Kotlin, you can see that it's going to automatically cast the vehicle object here to a bicycle in this case. And you can also see in IntelliJ, I'm not sure if you can see in the video, but in your editor, you will be able to see that the vehicle object here is also highlighted in green with a green background. And if you hover over it, it's also going to tell you it was smart cast to a bicycle. So the green background always means that a smart cast has happened, because inside this condition here, the compiler can actually infer that vehicle is of type bicycle. So it's safe to call the method replaceWheel, which only exists for bicycles. And similarly, you can go ahead and say else if vehicle is boat. Then of course you can similarly just go ahead and call vehicle.startEngine. So in this case, it's going to smart cast the vehicle object to a boat. So this is a very neat feature, but we can actually go a bit further with the examples, which is also going to be a bit of a logic exercise. So let's take a look at this. So what I can also do is I can say if vehicle is boat and vehicle.startEngine, then I'm going to do something that's not really important for us. The important thing here is that in the second part of our condition, the vehicle object was again cast to a boat. Now at this point, in order to understand why this is actually possible, it's important to know that just like in Java, Kotlin will only evaluate the second part of this condition if the first part here is true. And this is actually something that programmers make use of quite a lot. So whenever you have an AND operator in your condition, then Java and also Kotlin are going to go ahead, look at the first expression or the first part here, vehicle is boat. And if that part's already false, it's just not going to go ahead and even evaluate the second part, because if this first part here is false, then the whole condition can't be true anymore. So only if vehicle is of type boat, only then it's going to go into the second part here. So now the Kotlin compiler can again infer that vehicle is indeed of type boat. So again, it's going to be able to smart cast this to a boat so that we can call StartEngine. And similarly, you could also go ahead and say if vehicle is not instanceof or is not boat, and then use the OR operator for disjunction, then you can also actually call StartEngine, and the compiler can again smart cast this to a boat. Now I'm going to challenge you to think about why this is possible again with the same kind of reasoning that we did for the AND operator here. In case you're already familiar with this, you probably know why this works, but just think about in what cases the second part of the condition here actually has to be executed and in which cases it doesn't. So now the last example I want to do is if vehicle is not a bicycle, let's say, then we're just gonna return. So far no smart cast in here, but now after this block, you can go ahead and just call replaceWheel on this. And again, the compiler is just gonna smart cast this to a bicycle, because at this point at the execution, the vehicle object can only be of type bicycle, because if it wasn't of type bicycle, it would already have returned at this point. So I think it's just very interesting to see how clever the Kotlin compiler actually is, and in what kind of cases it can infer the type of an object, and will then just help you with smart casting the variable so that you don't have to write that kind of boilerplate code. So again, this increases readability. It also makes your code more concise, more understandable. So it's really a very nice feature, and well, there's really no drawback to it. Alright, so what you should take away from this lecture is that instanceof is called is in Kotlin, and whenever you have to do this, make sure to remember that Kotlin can use smart cast, so whenever you have something like this, there's no need to cast the object yourself. Just make use of smart cast and call the method you want to call. And also I think the other takeaway is just that the compiler is quite clever and can infer in many cases where it's possible that an object has a specific type. So that's all for this lecture. Thanks a lot for watching again. If you have any questions, let me know in the Q&A. And otherwise, I'm going to see you in the next lecture.